This is the physical setup for the experiment. We have a laptop controlling a Pasco 850 universal interface. That provides the voltage output that goes into our resistor capacitor network. Now let me come in a little bit closer here. I'll show you right here, the output voltage is coming out from these two ports here, from the red and the black wire. This is generating from the software a 350 hertz square wave with an amplitude of 5 volts. The red, the high voltage is coming in through here. You see it's coming in through this port through a 3900 picofarad capacitor. That in turn is connected through this blue wire to a 47 kilo ohm resistor, and that goes back to ground. Now across the capacitor we have a voltage sensor which is connected. That in turn goes back into the universal interface. So we will measure the voltage across the capacitor through that. Now here on the computer, I'm going to try to run this live while I'm holding my iPad. Wish me luck on this. So we have this set up to measure the voltage. When I click start, I'm going to be sampling at a very high speed, 250 kilohertz across the voltage sensor. So I'm going to hit record. We'll see if we can see this run live. There you can see the voltage came across. I'm going to zoom in a little bit so you'll see. You'll see much better data from this later on. You can observe in the light blue, you see the square wave coming out of the output voltage, out of the 850. So it's very fast rise and fall times, just almost infinitely fast, or almost zero rise and fall time. Now, the darker blue, this is the output of the voltage sensor. This is the voltage across the capacitor. So notice how there is some delay. This is what we've seen in the RC circuit. There's a finite rise time and fall time. So what we're going to do, I will collect some data and take some snapshots for you. You are going to measure the fall time for various cases. We're going to look at it from going from 4 volts to 2 volts, then 2 volts to 1 volt, 1 volt to half a volt.